Hi guys, this is Silvia speaking, MuSa team, and we are going to present you the evaluation done from the first delivery. So first of all, we submitted some surveys to our users to understand how the development process was going. And as you can see, many users, most of the users would like to have an interactive experience with MuSa. MuSa would have a great effect on the visits of the museum because users would come back. And also we feel that we are meeting the users' needs because most of them wouldn't suggest other functionalities other than the ones proposed. And also we are taking into account their opinion to design a user interface that would be to their liking. We also did a complexity and responsiveness analysis of our system. We wanted to be responsive, to follow the user real time, but also to keep the complexity low, to save the bot power and to have a minor amount of messages to process. This is also a matter of cost, because we want to push the limits of our fill plan that in Azure is 8,000 messages per day. And we achieve this by exploiting edge computing. For example, let's have a short evaluation of the following scenario. We have 30 STM Nucleo boards that send one message per second. We can see that if we send raw data to Azure directly, the free plan would expire in about 5 minutes, while instead if you use edge computing and the gateway, and the board gateway, the free plan will suffice for 11 hours. That is more or less the opening hours of a museum. Also, we evaluated with the backend with CodeCity, a tool we already presented, and as you can see, MuSa doesn't show any pathological patterns or classes, and this is good because it means that the code has low coupling and high cohesion. Also, we did also a sensor network reliability evaluation, and we noticed that having a single board as a gateway is a single point of failure. So to tackle this matter, we decided to use a redundancy approach. That means that we have a second Raspberry Pi in hot standby. More details on the Raspberry Pi as gateway in the architecture document. Which means that when the main gateway sends messages to Azure via MQTT, also the second Raspberry Pi board receives them, and if the second board doesn't receive messages from the main gateway in a certain amount of time, it would assume that the main gateway suffered a fault, and so it would take over its role as the main board. Finally, an update on the cost evaluation. Using Raspberry Pi has incremented the costs, and we also have to take into account the Wi-Fi and BLE expansions for STM Nucleo boards. So thanks a lot guys for watching this video, and stay tuned for other updates.